Hi, I'm David Coleman from eCall Marine. We're developing a brand new product that will be used to save lives in water. Working in conjunction with the European Space Agency at the Business Incubation Centre, eCall Marine is in the process and design of developing this whole new product. The product itself will be worn by a mariner or person at sea, leisure or a worker, and if that person falls into the water, it will automatically send a distress signal to the search and rescue services. Including the distress signal will be the ability to make an automated voice call directly into the emergency services. This creates two things that's never been done before. One, you can safeguard the person in the water, give them the reassurance that the rescue services are on the way. But two, from the emergency services point of view, they will be able to determine the reality of the incident and the severity of the need for a rescue. This will also go a long way to eliminate the false calls that the emergency response centres get on a daily basis. This is the eCall Marine platform, and today we're going to show you a simulation of what we expect emergency services to receive by way of data and voice. So as you can see from here, we have the longitude, latitude coming in from the person that's in the water. We also have it in westerns and northings. The unit ID is unique, and through a database we collect other information. So we know that Stephen James is in the water. He's 42 years old. He's attached to Annabelle 2, which is the vessel that he works on. He's a fisherman. The colour of the vessel is blue and white. These are all important pieces of information for the search and rescue operators. He operates out of Shamrock Quay in Southampton in the UK. And the owner of the boat is Stuart James, and there's his contact numbers. The incident time that the activation of eCall received was 13:27 and 16 seconds. And of course the date. So the first information's coming in, so we don't know the speed of the current yet or the heading. All we know is an elapsed time at the moment of 18 seconds since we received the call, and the geodesic is 61.7 nautical miles, which is a straight line flight to the person. So now the second elapsed time is 1 minute 32. We've now had 6 pieces of information come through. So what we can now do is determine that he's travelling at 4 knots and he's travelling in a west-southeasterly direction at 242 degrees. And we've launched the search and rescue helicopter from Lyon, Solent. Of course, as more information comes in from that, we can predict the plot of flow of the person in the water. And this is very important because we don't need the rescue craft to fly to where he was. We need to fly where he's going to be. So we take an algorithm which will include the launch time of the rescue craft, the speed of the rescue craft. We take in conjunction the knots and the direction they're channeling, and we have a POI, a point of intersection. So this way the rescue operator flies or boats directly to the person in the water. So you see here the point of entry into the water. We know the knots he's currently travelling at, and we've worked out the point of interception. These coordinates are obviously given to the search and rescue craft. The elapsed time now is 27 minutes and 18 seconds. And the ETA is 4 minutes 42 seconds. You can relay directly to the person in the water because you have open voice communication with them to the extent of the rescue operation and exactly at what point they are. This will give great comfort to the person in the sea. So eCall Marine sends new data every 20 seconds, updating the speed, the current, the drift, and fine-tunes the predicted point of intersection. If at any time during this point the current slows or speeds up, with every new piece of data coming in, it recalibrates the POI. This gives a far more precise point of intersection, especially if it's in darkness or in very bad weather. eCall Marine has, and is the only system that has auto voice. It speaks directly through the satellites, so it will work anywhere in the world in the major seas. The eCall Marine product is in the advanced design and development stage, and we're working with the likes of ESA and others. We see a timeline for launch will be first quarter 2018.